Why are electric car batteries so expensive? The cost of ingredients. In the case of Tesla, rather than make one gigantic battery or 6 huge battery modules, they chose an interesting method which creates cool space that prevents overheating, but also keeps 80% of TJE ingredients at a steady temperature, greatly increasing the battery life while allowing for faster charging. My extended range is composed of over 7,000 lithium-ion AA batteries, not actually AA but very close. The cost of a single battery is $1.25, or $8,300 for 7,000 of them, before 6 module holders, a special coolant circulator, fan, pump, computer hardware and software to control charging under 5 types of elect PNIC connections, and a half-dozen algorithms to control a half-dozen temperature conditions while driving and another half-dozen situations while charging, and a special anti-static protective case to protect cabin above and from road hazards below, so another $800 minimum, therefore roughly $9,100 plus $900 markup, or $10,000. The cost of mass production should get there down to $7,000 to $8,000 within the year. Because they are big, or in the case of Tesla, because there are so many. Below is the battery for my extended range Model 3, it has 4,416 cells, or 1,000 pounds of lithium-ion battery. A 2,170 cell, also shown, is $3.33 if bought individually, which would cost $14,000. Fortunately, Tesla produces 3 billion of them, so it is half that cost. The 350-volt Model 3 battery pack was made of 4 longitudinal modules, each containing the individual battery cells. The standard range version carries 2,976 cells arranged in groups of 31. The long-range version carries 4,416 cells arranged in groups of 46, and weighs 480 kg. The material to make them are not cheap. The prices have come down quite dramatically in the last 10 years due to automation and finding ways to use less of the more expensive ingredients like cobalt and lithium. The materials also have to be of high purity. A lot of people are working on improving battery technology, so I expect it to improve in price and performance dramatically in the next decade. As an example, some are developing batteries using sodium rather than lithium and getting a much higher power density. The electrical systems driving electrified cars work on 200 to 300 volts to substitute the gasoline-provided energy to propel cars. The chemical makeup of those batteries are no different from the one in your cell phone pocket, but they are made up of dozens of these cells in series, so replacing the car battery is like buying 100 iPhone batteries for your repair shop. If you are disappointed at what Apple does to throttle iPhone performance because of weak batteries, consider the horsepower lost in a Tesla when that happens. The Prius system can be bogged down with a malfunction indicator when just a few of these cells fail, causing the system voltage to drop to unacceptable levels.